Dear students, today we will discuss differential pulse code modulation. In starting, we first discuss few concepts of PCM, which is very important to understand the concept of differential PCM, because differential PCM is an extension of PCM. The thing is, in PCM, you first take an analog input, which is a band limited signal, and pass through a sampler, and the sampler converts this continuous signal into discrete sample values, and after that these samples is passing through a quantizer, which again can convert it into a equivalent quantized value as per the requirement of the system. Okay, then let us suppose this the value 2, 3, 3, 2, 1 and again 2 are the quantized value for the m delta t. Now the point is, after the quantized signal is received after the quantizer, we will take the MQT as the input to an encoder, and encoder will convert these two into binary equivalent bits. That the size of the output of the encoder depends upon the size of the how much bits is used to represent a one sample by the encoder. Now come to the point that after encoding value, that for example the 2 voltage is equivalent to 0, 1, 0, we are assuming that 3 bit of quantizer is used to convert this to volt. Again, in PCM we are seeing that 3 volt is the next quantized value, and it will be converted by the encoder in 0, 1, 1, and again after that 3 is again transmitted, then it will be the equivalent of 3 will be 0, 1, 1 again. Now the point is, in every case for PCM, in every case we are transmitting 2 minus 0, 3 minus 0, 3 minus 0 volt. That means we are sending the quantized value into the encoder. Encoder is converting the 2, 3 and again 3 voltage. The point is, the catch is that we in PCM we are sending the difference between the peak value and the lower value. That means 2 minus 0, again 3 minus 0, 3 minus 0. Now in DPCM, now the point is, in DPCM the first sampled and then quantized, which is again first quantized value, is sent to the receiver, and after that onwards the difference between two consecutive samples to consecutive samples is sent to the receiver. So for DPCM, let us suppose that if, as in this example, see 2 is transmitted first. So in DPCM, if 2 is transmitted, then the next value will be 3 minus 2. That means we are transferring the difference to the encoder, and encoder then convert it into the equivalent binary bits. So the catch is, the required bandwidth in DPCM is much less in comparison of PCM. That means bandwidth required in PCM is somehow greater than the bandwidth required in DPCM. I will again discuss that. The point is, in PCM, what are we sending? 2 and its equivalent binary value, 3 and its equivalent binary values, 3 and again its equivalent binary value, and the required bandwidth definitely is greater than in comparison of DPCM, where the only difference is transferring, where the difference is transferring from transmitter to receiver. See, in this case we have to quantized 1 volt, in spite of in PCM we are transferring the equivalent of 3 and again 3. So the bandwidth of DPCM is comparatively less in comparison of bandwidth of PCM.